everyone. So I am here to give you some insights about the question palindromic linked list. Okay. So now, before understanding this problem, you need to have clear understanding about what is a palindrome. Okay, and how linked list works. Basically, a singly linked list, because we are in this problem we are given a singly linked list. Okay, and we need to check whether this is of palindromic nature or not. Okay, so by palindromics it simply means if we reverse this, then then is it of uh, is it of same nature or not. Are the original values and the final value is same or not. Okay, so for example, Nitin is one example. So Nitin is a string, and if we reverse it, then the original one and the answer one and the and comes after reversal of this string are same. So similarly, in the case of linked list, what question says is, let's say if we have AB, BA, and if we reverse this linked list. Okay, if we reverse this linked list, then then after traversing both the original one and the answer one are giving same results or not. Okay, hope I am clearly understood. I hope I have given you insight about this problem, what basically it says. So now there are multiple ways through which we can solve this question. Okay, so one simple way is we can convert. So what, so let's say we what will happen if the if the data structure is not of linked list but array. What, and if we are required to check whether the array is of palindromic nature or not, what we will do, we will simply iterate from the start. We will just take two pointers and move ith one to the right hand side and jth one to the left hand side, and we'll check whether the answers are same or not. So let's take the same example of Nitin. So now if first we will iterate the ith pointer to the forward and jth pointer backward. So n is equal to n, we will move the I to the left and j to the right. Okay, now I is equal to I. Okay, I and j both reaches here. Now t is equal to t. Now I moves here and j moves here, and we will end the for loop. Okay, hope I am hope I have given you the insight, because we will just move till when I is less than or equal to j. Okay, so now, but we can't do the same thing with linked list. Okay, why? Because the linked list is not doubly, we cannot move backward like in the case of array, right? We cannot move backward. In the case of linked list we cannot take I here and j here and do the same fashion as we had done with array, right? So now, but what we can do, we can convert this linked list to an array. We can just take an array of same size, right? And just add the pieces here, and and do the same approach, and we got our answer, right? but what is the problem here? There is no problem here, the but there is a constraint of space complexity. Here we have a space complexity of o of n, right? Because we are making an n size array. N size mean n is the number of nodes, and we are making that size array. So we are taking space complexity of o of n. But the interviewer can say to us that we need to solve this question in o of one space. How can we do this in o of one space? Okay, so for this we can modify our linked list. How? So let's say we have the same example of Nitin. Let's say NIT I and N. Okay, now now to Now how can we modify this? We can just find the half middle of the linked list, middle of the linked list, and just reverse the second half or the first half. So for example, if we modify the second half, just to give you the same insight like the array. So if we reverse the second half, then the first half is this, and I have reversed the second half, and we can just traverse like an array and just check whether first is equals to second or not, and we have got our answer. And but okay, so in this way we can solve solve this question in O of one space. Hope I am clear here. Okay, but now there are multiple ways through which we can reverse the linked list. Okay, we can basically reverse the linked list. But before understanding this, we need to check how to find the middle of any linked list. So we can just count the number of nodes by in single traversal. We can find the number of nodes, and we can and the n by 2, and move again a pointer till the n by 2. I mean n by 2 times, and we will reach till the half of the linked list. And there is another approach of slow and fast pointer through which we can find the middle of the linked list. So for example, so in slow and fast pointer approach, what we will do is we will have slow and fast pointer, and fast pointer will move uh, two steps, and slow pointer will move only one step, and we will do this operation in till a fast is equal to fast reaches till null. Okay, okay, and the wherever the slow pointer is, that is our answer. Okay, so that this is, so wherever the slow pointer is, that is the middle of the linked list. And we can reverse the linked list. How? We can simply reverse the linked list. Use basically we can use stack as well to reverse the linked list, or we can, oh no, we cannot use stack because that will take O of n space. But we can do this use, we will already know how. We will just take a temp, basically previous, and temp1 and temp2, and we can simply reverse the linked list in O of one space. Okay, so temp1, first we will move first temp1's next to previous. Okay, and then temp1 will move to temp2, temp2 will move to temp1 will move to temp2, and temp2 will move to temp1 dot next, I mean this, and previous will move to temp. Okay, so in this way we can reverse the linked list. Okay, hope I am clear, and we can solve this question in O of one space in this way. Okay, thank you. I will attach the solution of my approach in the description, so you can see there. Thank you.